B. Chapter 3, NVM Express Architecture. 3.1, NVM Controller Architecture. A controller is the interface between a host and an NVM system, NVM subsystem. 3.1.1, Controller Model. This specification defines two controller models. Models. An NVM subsystem may support a static or dynamic controller model. All controllers in the NVMe subsystem shall follow the same controller model. And a static controller model, controllers that may be allocated a particular host may have different state at the time the association is established. The controller within an NVM subsystem are distinguished by their controller identifier. Or memory-based transport model controller shall support the static controller model. In a dynamic controller model, the controller is allocated by the NVMe subsystem on demand, and this model, all controllers allocated to a specific host have the same state at the time the association is established, including attached to namespaces and feature settings. Changes to a controller, for example, attached to namespaces, feature settings, after the association is the established do not impact other dynamic controller. NVM over fabric controllers in an NVM subsystem may use a dynamic or static controller model. A discovery controller shall support the dynamic controller model. An association is established between a host and controller when the host connects to a controller admin queue using the fabric connect command, referred to section 6.3. Within the connect command, the host specifies the host NQN, NVM subsystem, NQN, host identifier, and may request a specific controller ID or may request a connection to any available controller. A controller has only one association at a time. In a dynamic controller model, the controller is allocated by the NVM subsystem on demand with no state, for example, feature settings, preserved from prior associations. In a static controller model, a host may request a particular controller based on a controller ID where state, for example, feature settings, is preserved from a prior associations. While an association exists between a host and controller, only that host may establish connections within IOQs of the controller by representing a same host NQN, host identifier, NVM subsystem, NQN, and controller ID in subsequent connect commands using the NVM subsystem port, NVM transport type, and NVMe transport address. An association between address. An association between a host and a controller is terminated if the controller is shut down as described in section 3.6.2. A controller level reset occurs. The NVM sub-transport connection is lost between the host and the controller for admin queue or any IO queue, or an NVMe transport connection is lost between the host and controller for any IO queue, and a host or controller does not support individual IO queue deletion. Refer to section 3.3.2.4. There is no explicit NVMe command that breaks the NVMe support association between a host and controller. The disconnect command, referred to section 6.4, provides a method to delete an NVMe IO queue, referred to section 3.3.2.4. While the controller is associated with a host, the controller while the controller is associated with a host, The controller is busy, and no other association may be made with that controller. When using the connection controller models, a host shall specify a controller identifier of FFFH. When using the fabric connect command, refer to section 6.3 and to establish association with an NVM subsystem. When using the static controller model with a fabric connected controller, the state that persists across the association is any state that persists across the controller level reset. Additionally, different controller may present different feature setting or namespace attachment to the same host. The NVM subsystem may allocate particular controller to a specific host. While allocation of a static controller to host are expected to be doable, so that host can expect to perform association to the same controller repeatedly, for example, after each host reboot. The NVM subsystem may remove the host allocation of a controller that is not used in any time for implementation-specific reason. For example, controller resource reclamation and subsystem reconfiguration. 3.1.2 Controller types. As shown in Figure 20, there are three types of controller. An I/O controller, referred to as Section 3.1.2.1, is a controller that supports commands that provide access to user data stored on NVMe subsystem, non-volatile storage medium, and may support commands that provide management capabilities. An administrative controller, referred to Section 3.1.2.2, is a controller that supports commands that provide management capabilities but does not support I/O command that access to user data stored in NVMe subsystem non-volatile storage medium. A discovery controller, referred to as Section 3.1.2.3, is a controller used in NVMe over Fabric to provide access to a discovery log page. Figure 20. Controller types. And the controller type field in the identifier controller data structure is controller data structure indicate a controller type. Regardless of controller type, all controllers implement one admin submission queues and one admin completion queue. Depending on the controller type, a controller may also support one or more I/O submission queues and completion queues. When using a memory base to transport implementation, for example PCIe, a software submits command to a controller through a pre-allocated submission queues. A controller is alert to newly submitted command through the SQ tail lower register write. The difference between the previous lower register value and the current register write indicates the number of commands that were submitted. A controller fetches commands from the submission queues and processes them. Except for fused operations, there are no ordering restrictions for processing of commands within or across submission queues. Host software should not submit commands to a submit queues that may not be reordered arbitrarily. Data associated with the processing of a command may or may not be committed to the NVM subsystem non-volatile memory storage medium in the order that commands are submitted. All software submits command of a higher priority to the appropriate submission queues. Priority associated with the submission queue itself. Thus, the priority of the command is based on the submission queue to which the command was submitted. The controller arbitrates across the submission queues based on fairness and priority according to the arbitration scheme specified in section 3.4.4. Upon completion of command execution by the NVM subsystem, The controller presents completion queue entries to the host through the appropriate completion queues. If MXI and X or multiple messages MSI is in use, refer to the interrupt section of the NVM over PCI transport specification. Then the interrupt vector indicates the completion queues with a possible new command completions for the host to processes. If the pin-based interrupt or a single message MSI interrupt are used, host software interrogates the completion queues for new completion queue entries. The host updates the CQ head of doorbell register to release the completion queue entries to the controller and then to clear the associated interrupt. There are no ordering restriction for completion G to the host. Each completion queue entry identifies the submission queue identifier and command identifier of the associated with the command. Host software uses the information to correlate the completion with the commands submitted to the submission queues. Host software is responsible for creating IO submission queues and IO completion queues prior to using those queue pairs to submit commands to the controller. IO submission queues and IO completion queues are created using create the IO submission queue command referred to section 5.5 and the create IO completion queue command referred to section 5.4. Yeah. 3.1.2.1 The I/O controller. An I/O controller is a controller that supports commands that provide access to the user data stored on an NVM subsystems non-volatile storage medium using an I/O command set and may support commands that provide management capabilities. An I/O controller may simultaneously support multiple I/O command sets. The I/O command set that the controller supports and which of these I/O command sets that a controller simultaneously supports is reported in the identified I/O command set data structure. Refer to section 5.17.2.21. The contents of identify I/O command set data structure are not required to be same for all controllers in an NVM subsystem. Figure 21 shows an NVM subsystem with three I/O controller. I/O controller 1 has to attach its namespace, private name A and name shared name B. I/O controller 2 also has to attach namespaces. Private namespace C and shared namespace B. I/O controller 3 has no attached namespace. At some later point in the time, shared namespace B may be attached to I/O controller 3. The figure 1221. The NVM subsystem with the three I/O controller. NVM subsystem. Next is 3.1.2.1.1 command support. Figure 22 and Figure 23 define commands that are mandatory, optional, and prohibited for an I/O controller. I/O command set specific command support requirements are described within the individual I/O command set specification. The Figure 22 I/O controller admin command support. Okay, the command. Okay, delete IO submission queue, create IO submission queue, and get log page. Delete IO completion queue, and create IO completion queue. Identify, abort, set features, get features, asynchronous event request, capacity management, namespace management, firmware commit, firmware image download, device self-test, namespace attachment, keep alive, directive send, directive receive, virtualization management, NVMe MI send, NVMe MI receive, The doorbells, buffering config, lockdown, format NVM, security send, security receive, sanitize, property set, connect, property get, as authentication send, authentication receive, disconnect. IO command set a specific admin command. Vendor specific refers to application or applicable IO command set specification. Refer to applicable IO command set specification. Note: OMP definition or optional and mandatory P prohibited. Note 2: for NVMe over PCI implementation, keep alive command is optional. For NVM over Fabric implementation, the associated NVMe transport defines whether the keep alive command is optional and mandatory. For NVMe over PCI implementation or Fabric commands are prohibited. For NVMe over Fabric implementation, the commands are as noted in the table. Figure 23. IO controller, command IO command support. Command support requirements. Flush data set management. Reservation register. Reservation report. Reservation acquire. Reservation release. OMP definition. O optional, M is mandatory, and P is prohibited. Mandatory if the reservations are supported as indicated in the identifier controller data structure. The 3.1.2.1.2 log page support. Figure 24 defines log pages that are mandatory, optional, and prohibited from an IO controller. IO command set specific log page support requirements are described within the individual IO command set specifications. Figure 24 is IO controller log page support, log page name, supported page name, error information, small, health information, controller scope and namespace scope, and format slot information, changes namespace list, command supported and effect, device self-test, telemetry, host 2, or controller-initiated, endurance cream information, predictable latency event aggregate, asymmetric namespace access, persistent event, endurance group and event aggregate, media state unit status, a supported capacity configuration list, feature identifiers supported and effects, NVMe MI command supported and effect, command and feature lockdown, reservation notification, sanitized status, boot partition, rotational media information. An optional for NVMe Express Revision 1.4 and earlier. Mandatory controller supported fixed capacity management. And next is 3.1.2.1.3 feature support. Figure 25 defines the features that are mandatory, optional, or prohibited for an IO controller. IO command set specific feature support requirements are described within the individual IO command set specifications. Figure 25 is the IO controller feature support. Arbitration, power management, temperature threshold, volatile write cache, number of queues, interrupting coercing, entropy vector configuration, asynchronous event configuration, autonomous power state transition, host memory buffer, timestamp, keep alive timer, host controller thermal management, non-operational power state config, read and recovery level config, predictable latency mode config, predictable latency mode window, host behavior support, sanitize config, endurance group and event configuration. IO commands that provide software progress marker and software identifier reservation notification mask. Reservation persistence namespace write protection config names controller metadata and controller namespace rotational metadata or media. The feature mandatory the NVMe is overspace this PCIe. This feature is now supported for an NVMe over fabrics. Mandatory the reservation are supported as indicated in the identifier controller data structure. If the mandatory reservation are supported by the namespace as indicated by non-zero value in the reserved capabilities field in the identifier namespace data structure. This feature is optional for NVMe subsystems that do not implement a management endpoint. For an NVMe subsystem that implement a management endpoint to refer to an NVMe management interface specification. 3.1.2.2 Administrative controller. I think we need the okay. Thank you. Uh, right. 3.1.2.2 is next. 1.3.1.2.2 Administrative controller. An administrative controller is a controller whose intended purpose is to provide NVM subsystem management capabilities, while an I/O controller may support these same management capabilities. An administrative controller has fewer mandatory capabilities. Unlike an I/O controller, an administrative controller does not support I/O commands that access the user data stored on an NVMe subsystem non-volatile storage medium. NVMe transport may support a specific mechanism to allow an administrative controller to load undedicated NVMe management driver instead of a generic NVMe driver. Refer to the applicable NVMe transport binding specification for details. Examples of management capabilities that may be supported by an administrative controller include the following: ability to efficiently poll NVM subsystem status via NVMe MI using the NVMe MI send and the NVMe MI receive command. Refer to the NVM subsystem health status poll section in the NVMe management interface specification. Ability to manage an NVMe enclosure via NVMe MI using the NVMe MI send and the NVMe MI receive commands. Ability to manage NVM subsystem namespace using the namespace attachment and namespace commands. Ability to perform virtualization management using the virtualization management command. And the ability to reset an entire NVMe subsystem using the NVM subsystem reset and SSR register if supported. Ability to shut down an entire NVM subsystem using the NVM subsystem shutdown and SSD property. Since an administrative controller does not provide access to user data stored on NVM subsystems non-volatile storage medium, an administrative controller shall not support I/O queues and namespaces attached to the administrative controller. An administrative controller is required to support the mandatory admin command listed in Figure 28. An administrative controller may support one or more I/O command sets. When the administrative controller supports an I/O command set, then only I/O command set specific admin commands may be supported, since the administrative controller only has an admin queue and no I/O queues. The Figure 26 shows an NVMe subsystem with an administrative controller and two I/O controllers within an NVM subsystem that contains a non-volatile storage medium and namespaces. I/O controller 1 has two attached to namespaces, private namespace A and shared namespace B. So IO controller 2 also has two attached to namespaces, private namespace C and shared namespace B. Since an administrative controller does not to the uh, p- provide access to the user data stored on an NVMe subsystem and a non-volatile storage medium, the administrative controller has no attached to namespaces. The administrative controller in this example may be used for tasks such as NVM subsystem, namespace management, and efficiently polling NVM subsystem health status via NVMe MI. While this example shows a single administrative controller, an NVM subsystem may support zero or more administrative controllers. Figure 26. NVM subsystem with one administrative and two I/O controllers. Figure 27 shows an NVMe subsystem with an administrative controller within an NVM subsystem that contains no non-volatile storage medium or namespaces. The administrative controller in this example may be used to manage an NVMe enclosure using NVMe MI. Since the administrative controller is used for a very specific dedicated purpose, the implementer of such administrative controller may choose to implement only the mandatory capabilities along the NVMe MI and send an NVMe MI receive command. The figure 27 NVMe subsystem with one administrative controller. The 3.1.2.2.1 command support. Figure 28 defines command that are mandatory, optional, and prohibited for an administrative controller. Since an administrative controller does not support I/O queues, NVM command set commands that are not admin the commands are not supported. A host may utilize the command supported effect log pages to determine optional commands that are supported by an administrative controller. Figure 28 Administrative controller admin command support. So 3.1.2.2 and the log page support. Figure 29 defines the log pages that are mandatory and optional and prohibited for an administrative controller. Figure 29 Administrative controller log page support. And at 3.1.2.2.3 feature supports. Figure 30 defines features that are mandatory and optional and prohibited for an administrative controller. If any feature is supported, then the set features and gap features command shall be supported. I/O command set specific features supported requirement for I/O controller are described within the individual I/O command set specification. Figure 30 Administrative controller feature support. 3.1.2.3. Discovery controller. A discovery controller only implements features related to discovery log pages and does not implement I/O queues and I/O commands or expose namespaces. This functionality, supported by the discovery controller, is defined in section 3.1.2.3.4. The host uses well-known discovery service NQN and NQN 14.0.0 org. The connect command refers to section 3.6.3 to discovery service. The method a host uses to obtain the NVMe transport information necessary to connect the well-known discovery service is implementation specific. The discovery log page provided by a discovery controller contains one or more entries. Each entry specifies information necessary to for the host to connect an NVM subsystem. An entry may be associated with an NVM subsystem that exposes namespaces or a referral to another discovery service. There are no ordering requirements for log page entries within the discovery log page. Discovery controller may provide different log pages content depending on host NQN provided. For example, different NVM subsystems may be accessible to different hosts. The set of discovery log page entries should include all capable addresses on the same fabric as the discovery service and may include addresses on other fabrics. Discovery controllers that support explicit persistence connections shall support both asynchronous event request and keep alive command, referred to section 5-2 and 5-18 respectively. A host requests an explicit persistence connection to a discovery controller, an asynchronous event notification from the discovery controller on a persistence connection by a specific non-zero keep alive timer values in the connected command. If the connect command is specified a non-zero keep alive timer value and the discovery controller does not support the asynchronous event, then the discovery controller shall return a status value of a connecting valid parameters, referred to figure 383 for the connected command. Discovery controller shall indicate support for discovery log change notification and the identified controller data structure, referred to figure 275. Discovery controllers do not support explicit persistence correction, shall not support keep alive commands, and may use a fixed discovery controller activates timer value, for example 2 minutes. If no commands are received via such a discovery controller within the time period, the controller may perform the actions for keep alive timer expiration defined in section 3.9. A discovery controller shall not support the disconnect command. The discovery log page with the multiple discovery log page entries for the same NVM subsystem indicate that there are multiple fabric paths to the NVM subsystem, and or the multiple static controller may share a fabric path. The host may use this information to form multiple associations to controller within an NVM subsystem. Multiple discovery log page entries for the same NVM subsystem with different port ID values indicate that the resulting NVM transport connections are independent with respect to NVM subsystem port. Hardware failure. A host that uses a single association should pick a record to attach an NVM subsystem. A host that uses multiple associations should choose a different port. A transport-specific method may exist to indicate changes to a discovery controller. The controller ID values returned on discovery log pages entries indicate whether an NVM subsystem supported the dynamic or a static controller model. The controller ID value of the FFF hexadecimal H is a special value used for an NVMe subsystem that is supported by dynamic controller model indicated that any available controller may be returned. The controller ID of a FFFE is a special value used for an NVMe subsystem that is supported by a static controller model, indicating that any available controller may be returned. An NVMe subsystem supported the dynamic controller model if the discovery log page entries use the controller ID values of the FFFH. An NVMe subsystem supported that a static controller model if the discovery log page entries use the controller ID value that is less than FFFH. The identified controller data structure also indicates whether an NVM subsystem is dynamic or static. Then, if an NVM subsystem implemented the dynamic controller model, a multiple discovery log pages entries refer to figure 264 with the controller ID set to FFFH may be returned for the NVM subsystem, for example, to indicate multiple NVM subsystem port. In the discovery log page, if an NVM subsystem implemented the static controller model, then the multiple discovery log pages entries indicate different controller ID values may be returned for an NVM subsystem in the discovery log page. If an NVM subsystem that implemented that specific controller model includes any discovery log page entries that indicate a controller ID of FFFEH, then the host should remember the controller ID returned from the fabric connected to a command and reuse the allocated controller ID for future association to the particular controller. 3.1.2.3.1 Discovery Controller Initialization. The initialization process for a discovery controller is described in the Figure 31. The Figure 31 Discovery Controller Initialization Process Flow, and after the connect command completed with the status of a successful completion, the host performs the following steps. The NVM authentication is performed if required. Refer to section 13.2. The host determines controller capabilities by reading a controller capabilities property. The host figures the controller settings by writing the controller configuration property, including setting cc.en21 to enable command processing. The host waits for a controller indicates the controller is ready to process command. The controller is ready to process command when a CSTS is set to 1 in the controller status property, and the host determines the features and capabilities for the controller by issuing an identify command, specifying each applicable controller data structure. After initialization the discovery controller, the host reads discovery log page, refer to section 5.16.1.21. 3.1.2.3.2 Command support. The discovery controller supports all mandatory fabric commands. A discovery controller supports a subset of admin commands shown in Figure 32. Figure 32 is a discovery controller admin command support. 3.1.2.3.3 Log page support. The discovery controller shall support the discovery log page. The log pages that a discovery controller may support are shown in Figure 33. 3.1.2.3.4 Feature support. These features indicate the attribute of a discovery controller. Refer to Figure 34. This is optional information not required for a proper behavior of the system. Refer to the Figure 3 and 16. And the 3.1.2.3.4.1 Asynchronous event configuration. Feature identifier OB optional. Discovery controllers that are supposed to synchronous event notifications shall implement the get features and set features command. A discovery controller shall enable asynchronous discovery log event notifications. If a non-zero keep alive timeout Kato values is received in the connection command, refer to section 3.6.3. Sent to that controller. Figure 33 and 26 defines the discovery controller asynchronous event notification. 3.1.2.3.4.2 Discovery controller asynchronous event information request and notifications. If a discovery controller detects event about which a host has requested a notification, then the discovery controller shall send a asynchronous event with the asynchronous event type field set to notice Log phase identifier field set to discovery, and the asynchronous event information field set as defined in Figure 1 and 46. When a discovery controller updates discovery log pages, the discovery controller shall send a discovery log page changes asynchronous event notification. Asynchronous event information F0H to each host that requested asynchronous event notifications on this type. Refer to Figure 1 and 46. Okay, next is 3.1.3. That's the next time. 3.1.3 Controller properties. A property is a D-word or a keyword attribute of a controller. The attribute may have read, write, or read-write and access. The host shall access a property using with the specified that property with an offset that is at the beginning of the property unless otherwise noted in a transport specific specification. All reserved properties and all reserved bits within the properties are read-only and return a 0h when read. When read, the properties may be read with the property get command may be written to the property set command with the controller using the message-based transport model. For controllers using the memory-based transport model, refer to the applicable NVMe transport binding specification for access method and rules. For example, NVMe PCI transport specification. Figure 35 describes the property map of the controller. Accesses that can target any portion of two or more properties are not supported. Software should not rely on a 0h being turned. Figure 35, the property definition. And a property definition. The following conventions are used to describe controller properties for all transport models. Hardware shall return 0 for all bits that are marked as reserved, and host software shall write all reserved bits and properties with the value of 0h. The following terms are abbreviations are used. RORW, RWC, RWS, implement spec, and how we need it in the set. For some field, it is implementation specific, as whether the field is RW, RWC, or RO. This is typically shown as RW, RO, or RWC, RO to indicate that if the functionality is not supported, that the field is read-only. When a field is referred to a document, the convention used to use the property symbol field symbol. For example, the PCI command register parity error response enable bit is referred to by name CMD PEE, and if the field is an array of bits, the field is referred to as property symbol field symbol array offset to element. When a subfield is referred to in the document, the convention is used to is the property symbol, field symbol, subfield symbol. For example, when the controller ready with the media support subfield of the controller ready mode supported field with the controller capability property, the subfield is referred to by the name CAP, CRMS, and CRWMS. 3.1.3.1 Offset 0 CAP, controller capabilities. This property indicates basic capabilities of the controller to the software. Figure 36 offset 0H CAP controller capabilities. I think we needed to read this. Then figure 36 uh, 3 to 61 auto 0 description reserved 06 05 auto implement spec controller ready mode supported the CRMS. This field indicates the ready capability of the controller. Refer to section 3.5.3 and 3.5.4 more detailed bits. The controller CRWMS. This bit, if this bit is set to 1, the controller support controller ready with media mode. If this is clear to 0, then the control does not support control ready with the media mode. This bit shall be set to 1 on the controller compliant with the version later than NVMe 1.0 Express-based specification revision 1.4. Which 1. Control-ready independent media support CRIMS. If this bit is set to 1, then the controller supports control-ready independent of media mode. If this bit is clear 0, then the controller does not support controller-ready independent of media mode. 58. RO implement spec. The NVMe subsystem shutdown supported NSSS. This bit indicates whether the controller supports NVM subsystem shutdown feature defined in section 3.6.3. If the controller supports NVM subsystem shutdown feature, then this bit is set to 1. If the controller does not support NVM subsystem shutdown feature, then this bit is cleared to 0. If the NSSRS bit is cleared to 0, then this bit shall be cleared to 0. 57 auto impli spec impl spec. Controller memory buffer supported CMBS if set 1. The speed indicator the controller supports controller memory buffer, and that the address applied by host are permitted to the reference to the controller memory buffer only if the host has enabled the controller memory buffer's controller memory space. If the controller supports controller memory buffer, this bit shall be set to 1. 56 RO impl spec persistent memory region supported PMRS. This bit indicates whether the persistent memory region is supported. This bit is set to 1. If the persistent memory region is supported, this bit is cleared to 0. If the persistent memory region is not supported. 55 to 52 R0 impspec memory page maximum MPX max. This field indicates the maximum soft memory page size that the controller supports. The maximum memory which size is to power 12 plus MPX max. The host shall not configure a memory size page size in GC/MPS then is larger than this value. For this discovery controller, this field shall be clear to 0. 51 to 46, 8, arrow, input spec, memory page size minimum, MPS min. This field indicates minimum host memory page size that controller support. The minimum memory page size is 2 power 12 plus MPS min. The host shall not configure a memory page size in CC/MPS that is smaller than this value. For discovery controller, there shall be clear to 0H. 47 to 46 arrow input spec controller power scope CPS. This field indicates scope of controlling of the main power for this controller. Value 00 binary not reported. 01 controller scope. This is power scope. 10 is the domain scope. That is, the NVMe subsystem supports multiple domains. Refer to section 3.2.4. 11b NVM subsystem scope. That is, the NVM subsystem does not support multiple domains. If the NSSS bit is set to 1, then this field shall not be cleared to 00 binary. 55 arrow input spec. The boot partition support BPS. This bit indicates whether the controller supports boot partitions. If this bit is set to 1, the controller supports boot partitions. If this bit is clear to 0, the controller does not support boot partitions. Refer to section 8.2. 44 to 37 arrow info spec command set supported CSS. This field indicates the IO command set that the controller supports. Bit 7 is set to 1 if no IO command set is supported. For discovery controller, this bit should have only bit 0 set to 1. Bit 0 NVMe command set 5 to 1. 5 down to 1, reserved. 6. Controller support 1 or more IO command sets and support the identify IO command set data structure. Refer to section 5.17.2.21. Controller that support IO set command sets that other NVM command set shall not be. This bit is 1. Controller that only support the NVM command set may be set. This bit is 1 to indicate support for the command set identifier field in the command that use the command set identifier field. 7. No IO command set is supported. That is, only the admin command set is supported. 36 arrow input spec NVM subsystem reset supported NSSRS. This bit indicates whether the controller supports the NVM subsystem reset feature defined in section 3.7.1. This bit is set to 1 if the controller supports the subsystem reset feature. This bit is clear to 0 if the controller does not support NVM subsystem feature reset feature. For discovery controller, this field shall be clear to 0H. The 35 down to 32 arrow input spec, doorbell stride. Each submission queue and completion queue doorbell property is 32 bits in size. This property indicates the stride between doorbell properties. The stride is specified as 2 power 2 plus DSTRD in bytes. A value of 0h indicates a stride of 4 bytes, where the domain properties are packed without a reserved space between each property. Refer to section 8.8. For NVMe over fabric I/O controller, this property shall be clear to fix a value. Shall be cleared to fixed value of 0h. 31 to 24 RO input spec. The timeout TO. This is worst case time the host software should wait for csts.rdy to transition from 0 to 1 after CCEN transition from 0 1 to 1 or 1 to 0 after CCEN transition from 1 to 0. The worst case time may be experienced after events such as an abrupt shutdown to activation of a new form image. Typical times are expected to be much shorter. This field is 5 millisecond units. The maximum value of this field is FFH, which indicates a 127.5 second timeout. If the controller is independent of media enable CCCRIME, bit is cleared to 0, and the worst case time for CSTS.RDY to change state is due to the enabling the controller after CCEN transition from 0 to 1, then this field shall be set to the value in controller ready with medium timeout CRTO and CRWMT or FF if CRTO CRWMT is greater than FFH. If the controller ready independent of medium enable CCCRME bit is set to 1 and the worst case time for CSTS-RDY to change state is due to enabling the controller after CCEN transition from 0 to 1. This field shall be set to the value in controller ready independent of media time CRTO CRIMT or FFH if the CRTO CRIMT is greater than FFH. Controllers that support the CRTO register, referred to figure 62, are able to indicate larger timeouts for enabling the controller. Host software should use the value in the CRTO and the CRWMT or CRTO and the CRIMT depending on the controller ready mode indicated by CC and CRIME to determine the worst case timeout for a CSTS.RDY to transition from 0 to 1 to after CCEN transition from 0 to 1. Host software that are based on NVM Express revision 1.4 or earlier is not required to wait for than 127.5 seconds for CSTS.RDY to transition. Refer to section 3.4, and 3.4.5.4 for more information. And 23 to down to 19 is reserved as 0H. 18 to 17 is improved spec. Arbitration mechanism supported AMS. This field is a bit significant and indicates the optional arbitration mechanisms supported by the controller. If a bit is set to 1, the corresponding arbitration mechanism supported by the controller. Refer to section 3.4.4 of arbitration details. 0 is weighted round robin with urgent priority class, and 1 is vendor specific. The round robin arbitration mechanism not listed, although all controllers shall support this arbitration mechanism. For discovery controller, this process shall be clear to 0H. 16 is R0 input spec. Contiguous queues required CQR. This bit is set to 1 if the controller requires that I/O submission queues and I/O completion queues are required to be physically contiguous. This bit is clear to 0 if the controller supports I/O submission queues and I/O completion queues that are physically contiguous. If this bit is set to 1, then the physical contiguous bit cdw11.pc and the create IO submission queue and create IO completion queue command shall be set to 1. For IO controller and discovery controller using a message-based transport, for this property shall be set to value of 1h. Which 11.200 reset input spec description maximum queue entries supported MQES. This field indicates the maximum individual queue size that a controller supports. The NVMe over PCI implementation, this value applied to I/O submission queues and I/O completion queues that the host creates. For NVMe over Fabric implementation, this value applies to only I/O submission queues that the host creates. This is a 0 to base value. The minimum value is 1H, indicating 2 entries. The 3.1.3.2 offset 8H versus version. This property indicates the major and minor, the tertiary tertiary version of NVM Express-based specification that the controller implementation supports. Valid version of the specific are 1.0, 1.1, 1.2, 1.1, 1.3, 1.4, and 2.0. 3.1.3.2.1 VS value for 10 compliant controller. Figure 37 VS value for 1.0 compliant controller. The major version number and the minor version number. And the 1.3.1.3.2.2 VS value for 1.1 compliant controller and 3.1.3.2.3 VS value for 1.2 controller. 1.2.1 as a tertiary version number. Indicated tertiary version is 1. 1.3 compliant controller, and that is a 2.0 compliant controller. 3.1.3.3 offset CH INTMS interrupt mask set. This property is used to mask interrupt when using pin-based interrupt, single message MSI, or multiple message MSI. When using MSIX, the interrupt mask table defined as a part of MSIX should be used to mask interrupt. Host software shall not access this property when configured for MXX. Any access is when configured for MXIX undefined. For the interrupt behavior requirement, refer to the interrupt section of the NVM over PCIe transport specification. 3.1.3.8 offset to 4H AQA admin queue attribute. This property defines the attribute for the admin submission queue and admin completion queue. The queue identifier for the admin submission queue and admin completion queue is 0h. The admin submission queue's prior is in is determined by the arbitration mechanism selected. Refer to selection. Refer to section 3.4.4.3.4.4. The admin submission queue and admin completion queue are required to be in physically contiguous memory. Note: it's recommended that UEFI be used during boot operations in low memory environments like option ROMs in legacy BIOS environment. There may not be sufficient available memory to allocate the necessary submission and completion queues. In these types of conditions, low memory operation of controller is vendor specific. Figure 49, offset 24H, AQA admission queue attribute. The 927-16 RW 0H admin completion queue size ACQS define the size of the admin completion queue in entry. Refer to section 3.3.3.3. Enabling a controller while the field is cleared to 0H produced undefined result. The minimum size of the admin completion queue is 2 entry. The maximum size of the admin completion queue is 4,096 entries. This is a zero-based value. 11 down to 00, RW 0H reset value. The submission queue size ASQS define the size of the admin submission queue in and the entries. Refer to section 3.3.3.3, enabling controller while the field is cleared to 0 produces undefined result. The minimum size of the admin submission queue is 2 entries. The maximum size of admin submission queue is 4,960 entries. This is zero-based value. 3.1.3.9 offset 28 ASQ admin submission queue base address. This property defines the base memory address of the admin submission queue. Figure 50, offset 28H, ASQ, admin submission queue base address. 63.2.12, RW, input spec, the admin submission queue base ASQB. The field specifies the 52 most significant bits of the 64-bit physical address for the admin submission queue. This address shall be memory page aligned based on the value in cc.mps. All admin commands, including creation of IO submission queues and IO completions queues, shall be submitted to this queue. For the definition of submission queues, refer to section 4.1. Next is 3.1.3.10, offset 30H, ACQ, admin completion queue based address. This property defines the base memory address of the admin completion queue. Figure 51, offset 30H, ACQ, admin completion queue base address. 63.12 RW input spec, admin completion queue base ACQB. This field specified the most 52 most significant bits of the 64-bit physical address for the admin completion queue. This address shall be in memory page aligned based on the value in cc.mps. All completion queue entries for the command submission to the admin submission queue shall be posted to this completion queue. This queue is always associated with the interrupt vector 0. For the definition of completion queues, refer to section 4.1. 3.1.3.11. Offset 38. CMB controller memory buffer location. This optional property defines the location of the controller memory buffer, referred to section 8.1. If the controller does not support the controller memory buffer cap.cmbs, this property is reserved. If the controller supports the controller memory buffer and cmb msc.cre is cleared to 0, this property shall be cleared to 0h. Figure 20, Figure 52, offset 38H, CMB controller memory buffer location. Pitch 31 to 12, arrow, imp spec, offset, OFST, indicates the offset of the controller memory buffer in multiples of the size unit specified in CMBSG. 11 to 9, RO or 000 binary reserved. 08, RO ImpSpec, CMBQ dword alignment, CQDA. If the bit is set to 1, CDW11.PC is set to 1, and the address pointer specified controller memory buffer, then the address pointer in create IO submission queue command refer to figure 158 or create IO completion queue command refer to figure 154 shall be dword aligned. If this is clear to 0, then the IO submission queues and IO completion queues contained in the controller memory buffer are aligned as defined by the PRP1 field of create IO submission queue command. Refer to figure. Oh, sorry. What? So, as resumed, if the bit is clear to 0, then the IO submission queues and IO completion queues contained the controller right CMB buffers are aligned as defined as a PRP field of a create IO submission queue command, figure 168, 158, or a create IO completion queue command, figure refer to figure 154. Bit 07 arrow ImpSpec CMB data metadata mixed memory support CDM MS. If this bit is set to 1, then the restriction on data and metadata use of controller buffer memory by a command as defined in section 8.5 is not enforced. If this bit is clear to 0, then the restriction on data and metadata use of controller buffer memory by a command as defined in selection 8.5 is enforced. 06 arrow ImpSpec CMB data pointer and command independent location support CDP CILS. If this bit is set to 1, then the restriction that PRP, list, and SGL shall not be located in the controller buffer memory If the command that they are associated with is not located in the controller buffer memory is not enforced, refer to section 8.5. If this bit is cleared to 0, then the restriction is enforced. 05 RO input spec CMB data pointer mixed location support CPP MLS. If this bit is set to 1, the restriction that a particular PRP list or SGL associated with a single command or memory that is associated with a particular PRP list or SGL shall reside in either the control memory buffer or outside the control memory buffer. Control memory buffer is not enforced. Refer to section 8.5. If this bit is cleared to 0, then the restriction is enforced. 04 R0 R read-only RO input spec CMB Q physically discontiguous support CQPDS. If this bit is set to 1, the restriction that for all queues in a controller memory buffer, the queue shall be physically contiguous. It's not enforced. Refer to section 8.5. This bit is set to 0. This bit is cleared to 0. Then the restriction is enforced. 03 auto input spec CMB Q mixed memory support CQMMS. If this bit is set to 1, then a particular queue placed in a controller memory buffer, the restriction that all memory associated with that queue shall reside the controller memory buffer is not enforced. Refer to section 8.5. This is if this bit is cleared to 0, then the requirement is enforced. Bit 2 down to 0 RO input spec. Base indicator, sorry, I should read, okay, right. The base indicator register BIR indicates the base address register BAR that contains the control memory buffer. For a 64-bit BAR, the BAR for the least significantly 32 bits of the address is specified. Values 000, 010 binary, 011 binary, 100 binary, and 101 binary are valid. The addresses specified by the BAR shall be 4 KB aligned. 3.1.3.12 offset 3 CH CMB SG controller memory buffer size. This optional property defines the size of the controller memory buffer. Refer to section 0.1. If the controller does not support the controller memory buffer feature, or if the controller supports the controller memory buffer cap.cmbs and the cmbs.msc.cre is cleared to 0, then this property shall be cleared to 01. Figure 53 offset 3C H CMB SG controller memory buffer size 31 to 12 RO input spec size SG indicate the size of controller memory buffer available for use by the host. The size is multiples of the size unit. If the offset plus size exceed the length of the indicated bar, the size available to the host is limited by the length of the BAR. 11.2.08 RO input spec size unit SU indicate the granularity of the size field. 0H 4 kibibyte not giga 4 kibibyte 64 kibibyte 1 million 1 0 kibibyte memebyte 60 megabyte, 126 megabyte, 4 gigabyte, for 64 gigabyte, and the others are all reserved. 7H2FH 04RO ImpSpec Write Data Support WDS. If the bit is set to 1, then the controller supports data and metadata in the controller memory buffer for commands that transfer data from the host to the controller. For example, write, if the bit is clear to the 0, the data and metadata for command that transfer data from the host, the controller, shall not be transferred to the controller memory buffer. 03. Auto input spec read data support to RDS. If the bit is set to 1, then the controller support data and metadata in the controller memory buffer to command the transfer data from the controller to the host. For example, read, this bit is too clear to 0, the data and metadata for commands that the transfer data from the controller to the host shall not be transferred from the controller memory buffer. 02 auto input spec PRP SGL list support lists. If the speed is set to 1, then the controller support PRP list in the controller memory buffer. This bit is set to 1 and the SGLs are supported by the controller. Then the controller supports gather list in the controller memory buffer. If the bit is set to 1, then the submission queue supported init bit shall be set 1. If this bit is clear to 0, then the PRP list and the SGL shall not be placed in the controller memory buffer. 01. Auto input spec completion queue support. If the bit is set to 1, then the controller supports admin I/O completion queues and the controller memory buffer. If this bit is clear to 0, the completion queues shall not be placed in the controller memory buffer. 00RO input spec submission queue support SQS. If this bit is set to 1, then the controller supports admin and I/O submission queues in the controller memory buffer. If this bit is clear to 0, then the submission queues shall not be placed in the controller memory buffer. 3.1.3.13 offset 40 BPINFO boot partition information. This optional property defines the characteristics of the boot partitions referred to section 8.2. If the controller does not support boot partition feature, then this property shall be cleared to 0H. Figure 54 offset 40 BPINFO boot partition information. 30 bits 31 auto input spec the active boot partition APB-ID. This bit is indicated the identifier of the active boot partition. 25 to 24 auto 00B boot read status BRS. This field indicates the status of the boot partition read operation initiated by the host, writing to the BPR SEL.BPID field. Refer to section 8.2. The boot read status values are defined as 00 as no boot partition read operation requested, 01 boot partition read in progress, 10 boot partition read completion successfully, 11 error completing as a boot partition read. If the software writes the BPR SEL.BPID field, this field transition to 01B after successfully completing a boot partition read operation, that is, transferring to the contents to the boot memory buffer. The controller sets this field 10B if there is an error completing a boot partition read operation. The field set to 11B and the contents of the boot memory buffer are undefined. 14200 auto input spec boot partition size BPSG. The field defined the size of the each boot partition and multiples of 128 KB. Both boot partitions are the same size. 3.1.3.14 Offset 44H BPRSER Boot partition read select. This optional property is used to initiate the transfer of data in the boot partition referred to section 8.2 from the controller to the host. If the controller does not support boot partition feature, then this feature shall be cleared to 0H. If the host attempt to read beyond the end of the boot partition, that is, boot partition read offset plus boot partition read size, is greater than the boot partition size in bytes, the controller shall not transfer data and report an error at the BPINFO BRS field. Figure 55 offset 44H BPR SCER boot partition read select. 31 RWOB boot partition identifier BPID. This bit specifies the boot partition identifier for the boot partition read operation. 30 RO0 reserved. 29 to 10 RWOJ OH boot partition read offset BPROF. The field selected the offset into the boot partition in 4 KB units that the controller copies into the boot partition memory buffer. 0920 RW reset 0H boot partition read aside BPRSG. The field select the read size and multiples of 4 KB to copy into boot partition memory buffer. 3.1.3.15 offset 48 BP MBR boot partition memory buffer location optional. This optional property specifies the memory buffer that is used as destination for the data when a boot partition is read. Refer to section 8.2. If the controller does not support the boot partitions feature, then this property shall be cleared to 0. Figure 56 offset 48 PPMBR boot partition memory buffer location 6312 RWO boot partition memory buffer base address BMB BA with the field specify the 52 most significant bits of the 64 physical address for boot partition memory buffer. 1120 ROOH reserved. 3.1.3.16 offset 50H 50H sorry not 50 50H CM BM SE controller memory buffer memory space controller. This optional property specified how the controller references the controller memory buffer with the source supplied addresses if the controller supported the controller memory buffer CAP, CMBS. This property is mandatory. Otherwise, this property is reserved. This property shall be reset by neither controller reset nor function level reset, but this it shall be reset by all other controller level reset. Figure 57 offset 50 is a CMBMSC controller memory buffer memory space controller. 63 to 12 RW OH controller based memory controller based address CBA. This will specify the 52 most significant bits of the 64 base address of the controller memory buffers and controller register range. The controller memory buffers controller base address and its size determine each controller range. The specified address shall be varied only under the following conditions. No part of the controller memory buffer controller address range is greater than 264 minus 1, and if the persistent memory region's controller memory space is enabled, then the controller memory buffer's controller address range does not overlap the persistence memory region's controller address range. 0, 0, 01 RW reset value 0, controller memory space enable CMSE. The bit specify whether the address supplied by the host are permitted to reference the controller memory buffer. If CMB as MSSC.CRE is created to 0, this bit has no effect, and the controller memory buffer controller memory space is not enabled. If this bit is set to 1 and the controller base address is valid, the controller memory buffer's controller memory space is enabled. Otherwise, the controller memory space is not enabled. If the controller memory buffer controller memory space is enabled, then the address is supplied by the host. Therefore, within the controller memory buffer's controller address range shall reference the controller memory buffer. If the controller memory buffer's controller memory space is not enabled, and the no address supplied by the host shall reference the controller memory buffer. Instead, such addresses shall reference memory spaces other than the controller memory buffer. Bit 0, RW 0, capabilities register enable. This is specified whether the CMB, LC, and the CMB, SG properties are enabled. If this bit is set to 1, then the CMB LC is defined as shown in figure 52, and the CMB SG is defined as shown in figure 53. If this bit is cleared to 0, then the CMB SG and the CMB LC are cleared to 0H. 3.1.3.17 offset 58 CMB STS controller memory buffer status. This optional property indicates the status of controller memory buffer. If the controller is supported the controller memory buffer CAP CMBMS, this property is mandatory. Otherwise, this property is reserved. Figure 58 offset CMB-STS controller memory buffer status 31.2 down 31.201 auto H or 0H reserved bit 0 auto 0 bit controller base address invalid CBAI. This bit indicate this bit figure 58 offset 58 5A H CMB-STS controller memory buffer status. Controller address memory invalid CBAI. This bit indicates whether the controller has failed to enable the controller memory buffer controller memory space because the CMB MSC CBA is invalid. If CMB MSC CRE and CMB MSC.CMSE are set to 1, and CMB MSC.CBA is invalid, this bit shall be set to 1. Otherwise, this bit shall be cleared to 0. The 3.1.3.18 offset 5CH CMB EBS controller memory buffer elastic buffer size. This optional property identifies to the host the size of CMB elasticity buffer. Elasticity buffer. A value of OH in this property indicates to the host that no information regarding the presence or size of a CMB elasticity buffer is available. Figure 55-59 offset 5CH CMB EBS controller memory buffer elasticity buffer size 3120 auto input spec CMB elasticity buffer size base CMB WBG indicate the size of the CMB elasticity buffer. The size of the CMB elasticity buffer is equal to the value in the field multiplied by the value specified by the CMB elasticity buffer size unit field. The 4. Auto input spec. Read bypass behavior. If a memory read does not conflict with any memory write in the CMB elasticity buffer, that is, if the set of the memory addresses specified by a read is disjoint from the set of the memory addresses specified by all writes in the CMB elasticity buffer, that this bit is set to 1, then the memory read not conflicting with memory write to the CMB elasticity buffer shall bypass those memory writes, and clear to 0, the memory reads not conflicting with memory writes and the CMB elasticity buffer may bypass those memory writes. 320 RO input spec, CMB elasticity buffer size units, CMB as ZU, indicated the granularity of the CMB elasticity buffer size field. Value 0, 1, 2, 3, 4, 2F, granularity bytes 1 kibibyte, 1 megabyte, 1 gigabyte. The reserve kibibyte. The 1 dot 3 dot 1 dot 3 dot 1 dot 3 dot 19 offset 0 60 CMB SWTP controller memory buffer sustained write throughput. This optional property identified to the host the maximum CMB sustained write throughput. A value of 0H is in this property indicate to the host data information regarding the CMB sustained write throughput is available. Figure 60 offset Figure 60 offset 60H CMB SWTP controller memory buffer sustained write throughput. 3120 auto input spec. 자, CMB sustained write throughput, CMB SWTP indicate the sustained write throughput of CMB at the minimum payload size specified by applicable NVMe transport binding specification. For example, the PCIe TLP payload size as specified in the max payload size MPS field of PCI Express Device Controller (PXDC) register. The sustained write throughput of the CMB is equal to the value in this field multiplied by the unit specified by the CMB sustained write throughput unit cover, the unit field. 79 RO reserved. 32 RO in spec. CMB sustained write throughput unit CMB SWTU indicate the granularity of the CMB sustained write throughput field. 0, 1, 2, 3, 4 H byte per second, 1 kibibyte per second, 1 megabyte per second, gigabyte per second reserved. 1 dot 3.1.3.20 offset 64 and SSD NVMe subsystem shutdown. This optional property provides host software with the capability to initiate a normal or abrupt NVM subsystem or shutdown. Support for this property is indicated by the state of the NVM subsystem shutdown supported CAP and SSS field. If the property is not supported, then the address range occupied by a register is reserved. Figure 61 offset 64H and SSD NVM subsystem shutdown. 31200 RW0. The NVM subsystem shutdown controller and SSC a write of the value 4E726D6CH NRML to this field initiate a normal NVM subsystem shutdown for every controller. In the domain associated with the controller, when the CAP CPS is set to 10B as specified in the section 3.6.3.1, or the NVM subsystem when CAP CPS is set to 11B and the NVM subsystem as specified in the section 3.6.3.2. Write out a value 1 dot 4 dot 1 dot 416270 74H ABPT to this field initiate an abstraction NVM subsystem shutdown on the every controller. In the domain associated with the controller, when the CAP CPS is set to 11B as specified in section 3.6.3.1, or in the NVM subsystem when CAP and CPS is set to 11B and the NVM subsystem as specified in section 3.1.6.3.2. A write of any other values to this field has a functional effect on the operation of the NVM subsystem. This field shall return the value 0h when read. 3.1.3.21 offset 68H CRTO controller ready timeout. This property indicates the controller ready timeout values. This property is mandatory for controller compliant with the NVMe Express specification revision 2.0 and later. NVM Express based specification, figure 62 offset 68H CRTO controller ready timeout 31 to 16 R0 input spec. The controller ready independent of the media timeout CRIMT if the CAP CRMS dot CRIMS bit is cleared to 0, then this field is not applicable and shall be cleared to 0H. If the cap CRMS bit is set to 1, then this field contains the worst case time the most software should wait after CCEN transition from 0 to 1 for the controller to become ready to be able to successfully process all commands that do not access attached to namespaces and admin commands that do not require access to the media when the controller is controller ready independent of media mode. That is, the cc.crime bit is set to 1, attached to namespaces and the media required to produce admin commands may or may not be ready within this time period. Refer to section 3.5.3, section 3.5.4, and figure 01.103. This worst case time may be experienced after events such as an abrupt shutdown or activation of a new firmware image. Typical times are expected to be much shorter. This field is in 500 millisecond units. The value of this field should not be exceed FFH, that is 1 and 27.5 seconds. Controller ready with medium timeout CRWMT. This field contains the worst case time that the host software should wait after cc.en transition from 0 to 1. 4. Like the controller to become ready or be able to successfully process all commands and or attach to namespaces and the media required to process admin command to become ready, independent of which ready mode refers cc.crime, the crime, The controller is referred to section 3.5.3 and section 3.5.4. This worst-case time may be experienced after events such as a fraction shutdown or activation of a new firmware imaging. The typical times are expected to be much shorter. This field is in 5 millisecond unit. The value of this field shall be greater than or equal to the value of the CRIMT field and may be significantly larger than the value of the CRT or CRMT field. 3.1.3.2020 offset E00H PMR-CAP persistent memory region capabilities. These properties indicate the capabilities of the persistence memory region. If the controller does not support the persistence memory region feature, the property that this property shall be clear to 0. H. Figure 36 offset E00H PMR-CAP persistence memory region capabilities. 24 bits RO InfSpec controller memory space supported CMSS. If the set to 1, this bit indicated that addresses applied by the host are permitted to reference the persistence memory region only if the host has enabled persistence memory region's controller memory space. If the controller supports referencing the persistence memory region with the host supplied addresses, the switch shall be set to 1, otherwise the switch shall be cleared to 0. 23 to 16 auto InfSpec persistent memory region timeout PMRTO. This field contains the minimum amount of time the host software should wait for persistent memory region to become ready or not ready after PMRCTL.en is modified. This time in this field is expressed in persistent memory region time unit referred to PMRCAP.PMRTU. Then 13 to 10 auto input spec persistence memory region write barrier mechanism PMR WBM. This field lists mechanisms that may be used to ensure the previous write to the persistence memory region have completed and are persistent with the persistent memory region is ready and operating normally. A bit in the field, a, a bit in the field is set to 1 if the corresponding mechanism to ensure the persistence is supported. A bit in the field is clear to 0 if the corresponding mechanism is ensure persistence is not supported. A less than 1 bit in the field shall be set to 1. Bit 0, the completion of a memory read from completion of a memory read from any persistent memory region address ensures that all prior write to the persistent memory region have completed and are persistent. And the completion of read to the PMR-STS property shall ensure that all prior write to the persistent memory region have completed and are persistent. 9 to 0 auto input spec persistence memory region time unit PMRTU indicate the persistence memory region time units. 00 is 500 milliseconds, 01 is minutes. 102 to 11B is reserved. 7 to 5 auto input spec. Base indicate register BIR. This field indicates the base address register BAR. Let's specify the address of size persistence memory region. The values 012B and 011B. 11B and 10B are valid. 4 auto input spec. Write data support WDS. If the bit is set to 1, then the controller supports data and the metadata in the persistence memory region for commands that transfer data from the host to the controller. For example, write. If this bit is clear to 0, Then the data and the metadata for command that the transfer data from the host to the controller shall not be transferred to a persistence memory region. If the PMR cap.cmss is clear to 0, this bit shall be clear to 0. 3. R0 infospec read data support RDS. If this bit set to 1, then the controller supported data and the metadata and the persistence memory region for command that transfer data from the controller to the host. For example, read this bit is clear to 0, then the all data and the metadata for command that transfer data from the controller to the host shall not be transferred from persistence memory region. If the PMR kept CMSS clear to 0, this bit shall be clear to 0. 0 to 0 to auto 00B reserved. 3.1.3.23 offset E04H PMR-CTL persistence memory region control. This optional property controls the operation of a persistence memory region. If the controller does not support the persistence memory region feature, then this property shall be clear to 0. Figure 64 offset at E04 and a PMR-CTL persistence memory region controller. Bit 0 is RWO enable. EN. When set to 1, the persistence memory region is ready to process. PCI Express memory read and write request to once PMR-STS.NRDY is clear to 0. When the clear to 0, the persistence memory region is disabled and the PMR-STS.NRDY shall be set to 1. Once the persistence memory region is ready to be re-enabled. 1.3.1.3.24 offset E08 the PMR-STS persistence memory region status. This optional property provides the status of the persistence memory region. If the controller does not support the persistence memory region feature, this property shall be clear to 0. Figure 65 offset E0H PMR-STS persistence memory status region status. 12 R0OB controller based address valid CBAI. This field indicates whether the controller has failed to enable persistence memory regions controller memory space because the controller 64-bit address specified PMR-MSCU.CBA and CMR-MSCL are valid. If CMR cap CAP.CMSS is set to 1, CMR MSCL SMS is set to 1, and the controller 64-bit address specified PMR MSCU CBA and PMR MSCL CBI is invalid. This bit shall be set to 1, otherwise this bit shall be clear to 0. Health status HSTS. If the persistence memory region is ready, the field indicates the health status of persistence memory region. This field is always clear to 00 000B when the persistence memory region is not ready. These health status values are defined as 008B is normal operation. The persistence memory region is operating normally. 001B the restored error. The persistence memory region is operating normally and is processed. However, the content of the persistence memory region may not have been stored correctly. That is, may not contain the content prior to the last power cycle. NVM subsystem reset and controller level reset or persistence memory region disabled. 010B read-only. The persistence memory region is read-only. PCI Express memory write request to not update the persistence memory region. PCI Express memory read request to the persistence memory region return correct data. 011B Unreliable. The persistence memory region has become unreliable. PCI Express memory region may return invalid data or generate poisoned PCI Express TLP. Persistence memory region memory right may not update memory or may update memory with undefined data. The persistence memory region may also have become non-persistence. The 8 R0B not ready NRDY. This bit indicates the persistent memory is ready for use. If the bit is clear to 0, the CPR is CMRCTL.EN is set to 1. The persistent memory region is too ready to the accept and process PCI memory read and write request. If this bit is set to 1 or a CMRCTLEN is not clear to 0, the persistent memory region is not ready to process PCI Express memory read and write request. 70 RO 0, the ERR, and the persistent memory region is ready and operating normally. This field indicates whether the previous memory write to the persistent memory region has completed without memory. This field is clear to 0 H, then the previous write to the persistent memory region have completed without error and that values written by persistence. A non-zero value in the field indicate the occurrence of an error that may have caused one or more of the previous write to not have completed successfully. The meaning of any particular non-zero value is vendor specific. Once this field takes on a non-zero value, it maintains a non-zero value until PCI function is reset. 3 dot 1 dot 3 dot 25 offset E0 CH PMR EBS persistence memory elasticity persistence memory region elasticity buffer size. This optional property identifies to the host the size of PMR elasticity buffer. A value of 0H in this property indicates to the host that no information regarding the presence or size of the PMR elasticity buffer is available. Figure 66 offset E0CH PMR EBS persistence memory region elasticity buffer size. 31 to 8 arrow input spec PMR elasticity buffer size based PMR WBZ indicate the size of a PMR elasticity buffer. The actual size of the PMR elasticity buffer is equal to the value on this field multiplied by the value specified PMR elasticity buffer size unit field. 7 to the arrow input spec read by best behavior if a memory read does not conflict with any other memory write in the PMR elasticity buffer. That is, if the set of the memory addresses specify a read is disjoint from the set of the memory addresses specify or write in the PMR elasticity buffer. That is, and this bit is set to 1. The memory reads not conflicting with the memory write in the PMR elasticity buffer shall bypass those memory writes. Clear to 0, then the reads not conflicting with the memory write in PMR elasticity buffer may bypass those memory writes. Okay, next is PMR elasticity buffer size unit, PMR SGU. The indicated granularity of the PMR elasticity buffer size field. Value 0, 1, 2, and 3, the 4H2FH. Definition bytes 1 KB, MIGI, GIGI reserved. 3.1.3.26 offset 0 E10H, PMR SWTP, persistence memory region sustained write throughput. This optional property identified the host the maximum PMR sustained write throughput. A value of 0 is this property indicated the host that no information regarding the PMR sustained write throughput is available. 3120 auto input spec. PMR sustained write throughput. PMR SWTV indicate the sustained write throughput of the PMR of the maximum payload size specified applicable NVMe transport binding specification, that is PCI TLP payload size as specified in the max payload size MPS field of the PCI Express Device Controller (PXDC) register. The actual sustained write throughput of the PMR is equal to the value in this field multiplied by the unit specified PMR sustained write throughput unit field. The PMR sustained write throughput unit PMR-SWTU indicate the granularity of the PMR sustained write throughput field. 3.1.3.27 offset E14H PMR MSCR persistence memory region memory space controller OR. This optional property and the PMR MSCU property specified how the controller references the persistence memory region with the host supplied addresses. If the controller supports the persistence memory region's controller memory space PMRCAP.CMSS, this property is mandatory. Otherwise, this property is reserved. The host shall access this register with aligned authority B accesses. This property shall not be reset by controller reset. Figure 68 offset E1H E14H PMR MSCL persistent memory region space controller lower. The 31.212 RWOH controller base address CBA. This field specifies the least 20 significant bits of the 52 most significant bits of the 64-bit based address of the persistence memory region's controller address range. The persistence memory region's controller memory address and its size determine each controller address range. The 64-bit address, the base address specify the field and the CMR MSCU.CBA when the CMSE bit is set to 1 shall be valid only under the following conditions. No part of the persistence memory region's controller address range is greater than 2 power 64 minus 1, and if the controller memory buffer's controller main space is enabled, then the persistence memory region's controller address range does not overlap the controller memory buffer controller address range. 11 to 02 auto reserve. Bit 1 RWOB. Controller memory space enabled CMSA. This bit specified whether addresses supplied by the host are permitted to reference the persistence memory region. If this bit is set to 1 and the controller base to address is valid, then the persistence memory region is controller memory space is enabled. Otherwise, the controller memory space is not enabled. If the persistence memory region controller memory space is enabled, then the address is supplied by the host, then the for with the persistence memory region controller address range shall reference with the persistence memory region. If the persistence memory region controller memory space is not enabled, then no address supplied by the host shall reference the persistence memory region. Instead, such addresses shall reference may memory space other than the persistence memory region. The 3.1.3.28 offset E1H PMR MSCU persistence memory region memory space controller offer. This optional property and the PMR MSCL property specifies how the controller references to the persistence memory region with the host supplied addresses. If the controller suppose the persistence memory regions control the memory space PMRCAP.CMSS. This property is mandatory, otherwise this property is reserved. The host shall access the register with aligned 32-bit accesses. This register shall not be reset by controller reset. Figure 69 is offset E18 E80 no E18H PMR MSCU persistence memory region memory space control upper pitch 31200 RW0. The controller base address CBA. This field specified 32 most significant bits of the 52 most significant bits of the 64-bit base address for the persistence memory region's controller address range. The persistence memory regions controller base addresses and each size determine each controller address range. Next stage 3.2 NVM subsystem analysis.